Hello everybody and welcome to the lamest lecture ever. I'm no Mr. Anderson, so sorry, but we have to get done with notes. Okay, so last topic is about ozone depletion. Ozone depletion was first discovered in 1985. Occurs seasonally. More ozone in spring, less ozone in fall, as we previously discussed. And the reason for the ozone depletion was discovered to be the presence of certain human-made chemicals that were released into the atmosphere. These were going to be the chemicals from the halogen group. So chlorine, bromine, fluorine. And what scientists saw was that the ozone layer had decreased by 60% since the 70s, and that it was decreasing on average of 3% per year. The main cause was the presence of chlorofluorocarbons, more notably known as CFCs, that released into the atmosphere. CFCs had traditionally been used as refrigerants, aerosols, cleaning solvents, all those sorts of things. The problem with CFCs is they stay in the atmosphere for a really long time, like 200 years, and so the damage that was done by these CFCs is still being done in the atmosphere because the CFCs are still present. Okay. As of 1988, CFCs were banned in the US along with many other places in the world, but as I said, the CFCs are still doing their damage in the atmosphere because they are so long-lived. Okay, this is looking at, if it will come into focus. Well, this is looking at the ozone hole in our atmosphere over a 20-year period or so, and seeing that that ozone hole has grown over that time. That's what that one's showing. Okay. This is, why aren't you in focus? There we go, focus. Okay, this is showing the average amount of ozone in the atmosphere over a 50-year period, and seeing that that number has declined, and it is still continuing to decline because, as I mentioned before, the CFCs that were released prior to 1988 are still up there doing their damage in the atmosphere. Okay, this is showing a synopsis of the CFC problem. Okay, so we're looking at CFC being released from various human activities, and that as those CFCs are released into the atmosphere, they are broken down by sunlight, and that releases atomic chlorine, which is highly reactive, and that atomic chlorine then reacts with ozone and steals one of those oxygens to make chlorine monoxide and O2 gas. And what ends up happening as that ozone layer is destroyed, then more of those damaging ultraviolet rays can reach to Earth's surface and causes a whole host of problems for humans and also for other species. Okay, so this is a synopsis of the chemical reaction, and then we're going to also look at some other ways of seeing the chemical reaction. Okay, but this is the process for how ozone is depleted by the presence of CFCs. So ultraviolet radiation from the sun breaks the chemical bonds in the CFC and releases an atomic chlorine, which is highly, highly reactive. That atomic chlorine reacts with ozone to steal an oxygen from the ozone, forming chlorine monoxide and oxygen gas. Okay, the problem is this chlorine monoxide is not super stable either. That reacts with more ozone, breaking down that ozone and releasing atomic chlorine and forming oxygen gas. Okay, that chlorine then feeds back in to break down more ozone, forming chlorine monoxide and oxygen gas. And this thing happens over and over and over again. Okay, so it's a positive feedback loop. It feeds back into the system to create more ozone breakdown. Okay, and so this is why the molecule is so long-lived, because a single CFC molecule can end up destroying thousands upon thousands of ozone over its life. Okay, so here is a synopsis of that chemical reaction. So we have the UV radiation from the sun breaking down that CFC, that chlorofluorocarbon, freeing up the chlorine atom. That chlorine atom reacts with ozone to form chlorine monoxide. That's that right there. And oxygen. And then that that chlorine then can react with other ozone to free up that oxygen to form molecular oxygen, O2, and releasing that chlorine again, which then just goes on to destroy more ozone. Okay. And another look at the same thing. There's our CFC in the top left. There is our UV radiation from the sun breaking apart that molecule, freeing up that chlorine atom, which is going to then react with ozone. And that is going to form chlorine monoxide and O2. And then going to break apart more ozone to free up that chlorine atom again, forming more O2, and it feeds back in. And then right here, down in the bottom left, that is a summary of those chemical reactions for ozone depletion. And you need to make sure that you understand that. Okay, so UV light frees up chlorine. There we go. That chlorine reacts with ozone to form chlorine monoxide and oxygen, molecular oxygen. And then those free oxygens from the breaking apart of ozone are going to then steal that oxygen from chlorine monoxide, freeing up that chlorine again, which will just then go back into and repeat multiple times. Okay, so what happens when our ozone layer is depleted? We have increased ultraviolet radiation reaching Earth's surface, which increases skin cancer rates, increases damage from the sun, increases damage to the eyes, but then it also has effects on species other than humans, so reduced crop production, impacts on animals, reduced photosynthesis for phytoplankton and other plants which start food chains, looking at biodiversity loss, all sorts of things. Okay, also the stratosphere is no longer absorbing UV light, so that affects then our composition of the atmosphere and our warming trends in the atmosphere, which then has an impact on global climate patterns. Okay. This is just a reminder of, food chains, and if you're affecting the base of the food chain, then obviously you're affecting the entirety of the food chain that's dependent on that. This is just looking at skin cancer and increased risk of skin cancer due to increased ultraviolet radiation. That UV light, particularly those high energy, short wavelength UV light, has a tremendous amount of potential for damage to tissues as a mutagen, creating cancers. Okay, how can we go about reducing ozone depletion? Phase out ozone destroying chemicals, which we have already done. Ban the use of chemicals, which has already been done. Encourage individuals to produce ozone or to purchase ozone-friendly products, which is kind of a moot point because we are no longer producing chemicals that destroy ozone. Support legislation, which again is a moot point because this has already been done. Okay. How was all of this done? Through the Montreal Protocol. Montreal Protocol was started in 1987. They met again in 1990 and in 1992. And basically the idea was you're going to have this international agreement to get rid of ozone destroying chemicals so that we would stop the destruction of the ozone layer. And this is one of the few success stories in environmental science where we have identified a problem and got together the various countries of the world, agreed upon a solution, implemented the solution, and saw success. Now the problem is that, again, because the CFCs are such long-lived molecules, then they are still up there doing damage, but we have stopped the production of additional CFCs that would contribute further to this problem. All right, and that's the end of the notes. Thank you. Bye.